Hello, I hope this video finds you well. We're going to take the tool that we just wrote, which was base 10 to base 2, and we're going to generalize that to do base 10 to base n. And before we do this, let's take our process, our mathematical process for converting from base 10 to base 2 and generalize it to any base. So if you remember, converting from base 10 to base 2 is we just divided by 2 repeatedly until we hit 0 and took note of the remainders. And the same process works with any base. The difference is that we're going to have a different number of remainders. So if we want to convert to base 3, we have 0, 1, 2 that are valid digits. So our remainder could be 0, 1, or 2. And those are the valid numbers you will see in base 3. So I've kind of already done this here. I've taken 53 and I've divided it by 3, so that gives me 17 remainder 2. And then I take 17 divided by 3, and that gives me 5 remainder 2. And then I've taken 5 and divided it by 3, and that gives me 1 remainder 2. And then I've taken 1 and divided it by 3, which gives me 0 remainder 1. And I know I can stop now because I've reached 0. So what that tells me is that 53 in base 3 is going to be, reading from the bottom up, 1, 2, 2, 2. And now the question is, what does that actually mean? So recall that when we were talking about base 2, we talked about how, if we take a number, each digit represents a power of 2. And that's the same thing for base 3, but it's the power of 3. And so just think, for example, 343 or 341 in base 10. That's going to be 3 times 100 plus 4 times 10 plus 1 times 1. And we can think about this as 3 times 10 to the power of 2 plus 4 times 10 to the power of 1 plus 1 times 10 to the power of 0. And so this is how we basically convert any base value, is we start with 0, 1, 2. So let's take this base 3 value and convert it back into base 10 and confirm that we get 53. So 53 is equal to, and so now I'm going to start with the 1, so that's going to be 1 times 3 to the power of 0, 1, 2, 3, plus 2 times 3 to the power of 2, plus 2 times 3 to the power of 1, plus 2 times 3 to the power of 0. And that can be simplified now to 1 times 27 plus 2 times 9 plus 2 times 3 plus 2 times 1, which is equal to 27 plus 18 plus 6 plus 2, which is then, so 18 plus 2 is 20, and then 27, 37, 47, 47 plus 6, sure enough, is equal to 53. And that's the process of converting from base 10 to base 3 and then going back. And again, what I kind of want to highlight here is we think a lot about in computer science in base 2 because it's binary, but we can generalize this to anything. With that said, so now let's take this function that we wrote up here and let's generalize it. So I'm going to come down here and paste it below, and we're going to call this base 10 to base B. And the first thing I need to do is I need to add a second parameter so I know what base I want to convert it to. So in this case, if I wanted to convert 53 to base 3, I'm going to say base 10 to base B, 53, comma 3, saying that I want to convert it to base 3. And now what happens? Well, it's the same idea. I have this result string that I'm going to construct. I'm going to loop as long as n is greater than 0, but I'm not going to mod it by 2. I'm going to mod it by 3 if I want base 3, or b if I want base b. And I'm not going to integer divide by 2. I'm going to integer divide by 3 if I want base 3, but I'm going to integer divide by b if I want base b. And that's it. So now if I save this, and I pull up here, and I run this, there's that value. There is 53 in base 3. And so this is just a really nice extension of this tool. A lot of students will learn how to go from base 10 to base 2 because they're in computer science. But you can generalize this to any base, and it's just a wonderful kind of way to kind of expand on your skills. If you have any questions, please don't hesitate to reach out. Have a great day.